Welcome to ResourceCast. ResourceCast every week examines answers to hard questions that confounds the natural resource industry. I am Hari Tulsidas, your host for the show. My thanks to the growing community who are listening to this podcast. Your comments also will be very helpful for us. Today is Sunday, 1st March 2020. In the last few episodes, we discussed a little bit about artificial intelligence. Artificial intelligence has got a great role to play in many of the emerging technologies that are being developed to solve a lot of society's problems. Today, let us think how artificial intelligence can help natural resource industry in different ways. I will start with the issue which we discussed in the last episode. That is, artificial intelligence being used to explore for oil and gas resources or mineral resources. Can artificial intelligence support enhanced discovery of resources? This is what many companies are believing today. So as we discussed in the last episode, a lot of oil and gas industries are investing in systems which are AI enabled and cloud based. Maybe moving forward, we will hear something about quantum computing and super intelligent machines and machine learning and things like that. But today, the discussion is confined to understanding how artificial intelligence and cloud computing can support oil and gas discoveries. Maybe also AI can support enhanced recovery of oil and gas. In the mining side, it can help in understanding some of the difficult mining questions. But the question is it an effective tool? And how far this hype of AI really is helping the industry. Before going into the details on how AI can help with oil and gas or mineral discoveries, let us spend some time to think about artificial intelligence itself. When we talk about artificial intelligence, there are three ways in which we can understand the concept. One is having a machine, such as a computer, behave in a way it has some intelligence. The intelligence is not at the same level with human intelligence, but it is better than normal PC, laptop, or a calculator. Some independent thinking of its own. It can solve some of the tasks which is beyond what a normal software can solve. The second way of seeing artificial intelligence is to see it as equivalent to a human brain. Artificial intelligence enabled machine will be indistinguishable from a human being. It can act as if it is a human being. The third way we can think about artificial intelligence is having a system which can excel human brain in a kind of a superhuman intelligence paradigm. For several decades, AI research have shown that replicating a complex problem-solving and abstract thinking of a human brain is very difficult. For one thing, we human beings are very good at generalizing knowledge and applying concepts we learned in one field to another. We can also make reliable decisions based on intuition and with little information. These basic elements of a human being, that is, taking reliable decisions based on intuition and which are very little connection to facts, is a unique feature of the human brain. Some animals could also have developed certain capabilities towards that human intelligence, but it is for the human beings to act in a way that it is more belief-based than facts-based. When you think about the human interaction or human brain's interaction with the outside world, we have to see it as two different processes. One is called induction and the other one is called deduction. Induction is the whole concept of generalizing knowledge. We can see induction as a kind of model making. So we make some models, and models are essentially simplification of the reality. When we see with our eyes, we hear with our ears, we feel through our skin the external world. We are not taking into cognizance every single thing of the external world. We are imbibing only certain key aspects of the external world. So what we are doing is we are doing a simplification of that. And we make a model based on that simplification of information. And essentially it means that it is not the factual truth which we make as rules in our cognitive thinking. This is called the process of induction, making simplified models. Once these models are available to the human beings, what we do is we examine the external world and categorize the world based on these rules. And this process is called deduction. So based on an existing simplified model, we are understanding the external world, maybe through categorization or maybe through just one sample understanding. Induction and deduction are the two important basic fundamental concepts we have to understand when we are talking about cognitive aspects, cognitive ability of the human brain. Now, when we think about artificial intelligence and how we can make machines which are capable of human-like intelligence, we have to think how we can replicate this process of induction and deduction. With experience, what we have seen is that deduction is very easy. If you give the machine a simple model or a simple set of rules, it can use that rule or model to understand whatever data it is given. But the process of induction, creating the model or a simplified model or simplified set of rules is extremely difficult for a computer or an artificial intelligence system to do. This is where the artificial intelligence has a big challenge today. How this science can develop a reasonably good process of seeing how induction can be enabled, how reliably they can replicate induction. So this is the challenge we have today before artificial intelligence. Let us look into different types of artificial intelligence, just to put us in a perspective to discuss how this could be useful for our various tasks. We talk about a narrow artificial intelligence or a weak artificial intelligence that doesn't aim to reproduce the functionality of the human brain and instead focuses on optimizing a single task. So this is the first construct I described, having an artificial intelligence system which is inferior to the functioning of a human brain. Such a system is called a narrow AI or a weak AI, is very good in doing some simple tasks, recognizing faces, transforming audio to text, recommending videos on YouTube or Netflix, displaying personalized content in Facebook newsfeed, etc. These are all the work a narrow AI can do very well. Narrow AI can help automate repetitive tasks and laborious tasks and help humans become more productive. For example, doctors can use AI algorithms to examine X-ray scans at high speeds, allowing them to see more patients. This narrow AI can be used to fight cyber threats. Security analysts can use AI to find signals of data breaches in gigabytes of data being transferred through their company's networks. The other side of artificial intelligence is known as general artificial intelligence or GAI, or sometimes it is called artificial general intelligence, AGI. Stephen Hawkins called general artificial intelligence. Full artificial intelligence could spell the end of the human race. In 2015, Y Combinator President Sam Altman and Tesla CEO Elon Musk, two great believers in AGI, co-founded a company called OpenAI, a non-profit research lab that aims to create artificial general intelligence in a manner that benefits all humankind. Elon Musk had since departed from this organization, but this organization is continuing to develop what is known as open AI systems, which are capable of mimicking human intelligence. Narrow artificial intelligence versus general artificial intelligence can also be called rule-based AI and machine learning. Rule-based AI transforms human knowledge and intelligence into static rules. Machine learning engineers, on the other hand, train the models by providing them a massive amount of samples. Deep learning, a subset of machine learning, has become very popular in the past few years. It is especially good at processing unstructured data such as images, video, audio, and text documents. For instance, you can create a deep learning image classifier and train it on millions of available labeled photos. Even with narrow artificial intelligence, oil and gas exploration or mineral exploration can automate several tasks and make it more productive and faster than what could be achieved by a human brain. For example, one area in which oil and gas companies are giving emphasis on AI today is on using AI to interpret seismic data. This is an area that could be very productive, that could give good results much faster than in the case of a human brain that is interpreting the data. Now, let us have a look at a more structured way on which artificial intelligence is understood. People say that there are 7 types of artificial intelligence. So let us have a look at all these 7 types of artificial intelligence very briefly. Responsive machines are one basic type of artificial intelligence. They can copy the human personality's capacity to react to various types of improvements. A prominent case of receptive AI machine is the famous IBM's Deep Blue machine. This is a computer that defeated chess grandmaster Garry Kasparov in 1997. Constrained memory machines are a second category. Such machines are additionally fit for gaining from chronicled information to decide on certain things. Practically all present-day artificial intelligence applications, from chatbots to menial helpers to self-driving vehicles, are all basically constrained memory machines. Hypothesis of the mind, artificial intelligence, is a replication of the psychological construct called theory of mind in artificial intelligence. Theory of mind is an understanding of the human brain that another individual also has a mind of his or her own. Such a thinking is very important because we have to understand that whatever we have as a self-contained mind is also present in another person. Such an understanding comes only at an age of 3 or so in the human brain development. Children below the age of 3 doesn't have that understanding. So this understanding that other people also have their mind of their own is called the theory of mind. And replicating that kind of an understanding in the machines will be a great step. The next category of AI is mindful AI. Now, mindfulness is a mental state achieved by focusing one's awareness on the present moment while acknowledging and accepting one's feeling, thoughts, and bodily sensation is sometimes used as a therapeutic technique. Mindfulness meditation is very common today, and it is also a concept which is very close to yoga. Being detached from whatever that is happening around you. Be fully aware of your surroundings, but don't be controlled by that. If good things are happening, don't be overjoyed in that. If bad things are happening, don't be overtly distressed by that. This is called detachment or samachitta in the Hindu literature. So having an artificial intelligence which is mindful is another step in the development of AI. Now, coming to the basic 3 types of AI I explained earlier, we can call it as artificial narrow intelligence, ANI, which is AI that can play out a particular undertaking independently utilizing human-like capabilities. Artificial general intelligence, or AGI, is to see, learn, and comprehend and work totally as a person. The third type of artificial intelligence is called artificial superintelligence, a kind of AI that will be doing everything exceedingly better and prominently. Artificial superintelligence will be exceedingly better at all that they do in view of overwhelmingly more prominent memory, quicker information handling, examination, and basic leadership abilities. That is the type of AI that will exceed human intelligence. Today, whatever artificial intelligence we have is at the lower end of the spectrum of these three types of artificial intelligences. That is artificial narrow intelligence. And within artificial narrow intelligence, most of the better kind of AI we are seeing today, like self-driving cars, etc., they come under the category of constrained memory. Artificial general intelligence and artificial super intelligence are aspirational targets which we have today. We have not reached anywhere near to these goals. So where do we find artificial intelligence applications today? Some of the advanced areas where AI is being tested are in self-driving cars, digital assistants and smart speakers, translation, face recognition, medicine, and few other fields like that. Oil and gas exploration and mineral exploration also now are emerging as new fields in which AI could be enabled. Mineral exploration over centuries and oil and gas exploration over the last few decades have always relied only on human brain in its day-to-day tasks. It is true that some computational features were helping the world of exploration in the last 2 decades or so, 2 or 3 decades. And the most prominent tool is Geographical Information System or GIS. For mineral exploration, satellite data and airborne data have proven to be very profitable, and therefore a lot of computational power has been used in understanding and interpreting satellite and airborne data. Similar data is also used in oil and gas exploration, but oil and gas exploration has more utilized the ground-based geophysical data, especially geophysical data which has been generated from bore wells. So one of the most important data set which oil and gas exploration always uses is seismic data. And seismic data is used to understand how different layers are there in a given basin. To understand the boundaries between especially shale and sand is very important to get into the reservoir. And seismic data is very helpful in getting this information. Failure rates in oil and gas and mineral exploration historically has been very high. In mineral exploration, as a thumb rule, without having any real data before us, it is always said that if you have 10,000 occurrences, 100 of that will become mineral prospects. That means areas which are defined for exploratory drilling and other ground-based activities. And from that 100 prospects, about 10 will develop as detailed investigation blocks where a large density of boreholes will be drilled. And from that 10 detailed investigation blocks, maybe one mine will ultimately emerge. The whole process of exploration, whether it is in minerals or in oil and gas, is narrow downing these targets from an initial 10,000 or 100,000 to 100 prospects to 100 blocks where detailed investigations can be done and to one mine producing well. So one area where the industry was looking for improvements is to reduce these failure rates or how we can efficiently narrow down these areas. So instead of looking for 100 prospects, can we directly narrow our target areas to just one area which could prove to be productive? One way to reduce mineral exploration failure rates will be to see how we can have more exploration inputs. That means spending more money into exploration. Currently, only 2% of the mining expenditure is in exploration. So naturally, if you are increasing your exploration resources, then you are naturally proving the way in which you are working in exploration. Bringing in AI will bring in more resources. So in effect, putting more money into exploration, which was what experts, especially exploration geologists, have been demanding for a long time. Having AI in exploration, especially in the oil and gas areas, will be to see how we can do the interpretation of geophysical data, especially seismic data, more accurately and much faster than what we are achieving today. More than 20 years back, I remember when we were discussing about 3D seismic data, which was becoming very popular at that time. There were several remarks that there is only one person in the world who can do very good interpretation of this data. Someone, I don't remember the name, person who was sitting in a laboratory in Texas. He was the only person who can interpret 3D seismic data in a very effective manner. And all the companies in the world will be dumping him this data for interpretation. So his time is limited. He has only 8 hours of working time in a day. So he will be looking at this data one after another. And it will take several months before he could interpret a certain set of data. Even today, we have reports that it will take several months before 3D seismic data could be interpreted. So this is one of the bottlenecks that the industry has today. And my assumption is that oil and gas companies are investing in artificial intelligence. They are looking into ways in which they can reduce this lead time in interpreting the data they have generated. You have to understand that 3D seismic data are generated within a short time, but then it will be lying for several months or years before they get interpreted. And the results come based on which the next set of activity could be planned. This is a case in mineral exploration also, where seismic data is not normally used, but several other geophysical sets like electromagnetic are used very frequently. But the interpretation of this data is one thing that is very difficult. We have, especially in the airborne electromagnetic data interpretation, maybe 2 or 3 companies in the world who can do that with a fair amount of reliability. All others who are doing interpretation of this data are more or less at the same level as amateurs. Companies who are spending a lot of money in producing this data will have to go to this, are at the mercy of these 2 or 3 companies to get it interpreted. And once you have it interpreted only, they can think about what they have to do in their next steps in exploration. So if the promise of AI is that it can do this interpretation of geophysical data, that will be a big boon to the oil and gas and mineral industry. So developing AI, I think in the initial phase will be to interpret geophysical data so that this tyranny of depending on a few individuals or few companies could be overcome. But the question is, will the machines be able to interpret in a data which could be much more reliable and fault-free than what a human being can do? My assumption is that the AI, once it starts getting applied to interpretation of geophysical data, will be starting at a very low threshold, and it is likely that it will improve its interpretation capabilities as it learns and understand this process better. It could be reasonable to imagine that the interpretation capability of AI will be improving and getting better and better with time so that it can reach to a certain extent of the human capabilities. But the important question is, can AI provide interpretation that can excel in human beings' interpretation? This is something that will be interesting to understand. We know that nature is not made of simple rules. If we want to understand the relationship between 2 bodies like Earth and Moon, the solutions are very easy. If there are a lot of objects, like a certain amount of sand grains, if you count the number of specimens in that small volume of sand, it could be a number which is closer to infinity. In such conditions, statistical techniques will apply. It can provide very good results. Now, in the 2-body problem where certain very simple physical laws can apply, you put in a 3rd body, it becomes a 3-body problem, and it becomes vastly complex than a simple 2-body problem. Unlike 2-body problems, no general closed form solution exists for 3-body problems, as the resulting dynamical system is chaotic for most initial conditions. But still, if you have a limited number of bodies like solar system with sun, moon, and other planets, there are effective numerical modeling methods which can generate good understanding of the system. But most of the geological problems or natural world problems doesn't fall in this area of simple rules like two-body or three-body problems, and the statistical world of aggregates like sands or a population in a country, etc. According to the writer Nassim Taleb, the whole world and its objects and things and processes, happenings, all could be divided into a safe and comfortable mediocristan world and an unsafe and improbable extremistan world. Mediocristan is a world of physical rules in one side and statistics in the other side. We can reasonably understand the system and predict what is going to happen in the system. Simple calculations, mathematical modeling, and statistics are enough to understand mediocristan. Extremistan occupies a huge area between these two extremes. It is an area that is very difficult to understand and predict. In the seminal work, General Principles of Systems Design, Gerald Weinberg in 1988 has written about this area construct which Nassim Taleb calls extremistan as an area of organized complexity. Weinberg, in a two-dimensional graph in which one axis represents complexity and another axis on randomness, divided the whole world into three. At the bottom, it is organized simplicity, the world of machines. Very simple rules apply there. At the top, there is the region of unorganized complexity. This is an area where aggregates like sands or human population or plant population, etc. exist. In the middle, there is a large area in which systems exist. This is an area which he called organized complexity. It is an area that is too complex for analysis and too organized for statistics. Most of the Earth systems fall in this area of organized complexity. So having artificial intelligence to understand this world will be a challenge in itself. It should have at a minimum human-like capabilities, which we call AGI, artificial general intelligence. But most probably it should have artificial super intelligence to understand it properly. If you look at mediocristan, it has got mild randomness. Most typical member is mediocre. It is easy to predict. It has got normal curves and its total is equal to a sum of many small events. Human population. In human population, if you are measuring the height of individuals, it falls under mediocristan world. Easy to predict. The most typical member of human population where height is considered is mediocre. You don't see 1 centimeter tall human beings or 2 kilometers tall human being in a human population. Extremistan, on the other hand, deals with extreme randomness. There is no typical member in a population in extremistan. It is hard to predict and it follows what is known as the Pareto curves, which very broadly can be explained as 80 to 20 rule. 80% of the people doing 20% of the task, etc. The total in extremistan is the sum of a couple of huge events. For example, the wealth of people in a country is that 2 or 3 people or 10 top richest people will have 90% of the wealth. So something like that fall as examples of extremistan. What we have to see is natural systems are complex and hence difficult to understand and manage. Complex system is a system composed of many components which may interact with each other. Natural ecosystems are best examples of complex systems and can be decomposed into structured underlying processes. Complexity doesn't refer much to the properties of the individual components in the system, but rather to their relationship and complex behavior with each other. Complex systems have distinct properties that can arise from these relationships, such as non-linearity, emergence, self-organization, adaptation, feedback loops, and other things. Non-linearity of complex system means it may respond to different ways to the same input depending on their state or context. The butterfly effect is a common metaphor. The flapping of wings of a butterfly can cause a storm halfway across the globe. Emergence, in the same manner, refer to traits of a system that are not apparent from its components in isolation, but which results from interactions, dependencies, or relationship they form when placed together in a system. Self-organization or spontaneous order is another important feature of a complex system. An example of emergent behavior can be found in insect world, where colonies of simple creatures like ants or termites or honeybees will form together spontaneously to build very complex structures like underground colonies or mounds. Natural systems are also adaptive. They have the capacity to depend on feedbacks. We may think that complex systems like this are more appropriate when we are talking about a living world. But as I have discussed in the last episode, life on Earth and mineral systems or Earth systems or geology are not mutually exclusive. I have set the example of plate tectonics, which is essential for a living planet. And it is to a large extent the life on the planet that drives the plate tectonics also. Today we are learning a lot about human brain. There is a lot of data that has been generated at a neuron level. But as more and more data is being accumulated, we are seeing that big data is not knowledge as far as brain is concerned. We are drowning in a flood of information. Emergence is seen as a key feature in understanding human brains. And if you go deeply into the question of emergence, we can see there is a weak emergence and a strong emergence. The human brain, which is consisting of various individual segments of its own within the whole, work together in a way in which consciousness emerges as a consequence of it being a complex system. Also, we have to see that human brains are not very perfect machines. And the basic reason why human brains have got certain disabilities is that it has emerged in the dark depths of oceans where visible light was very weak. So the perception, eyesight was of short distance, and human brains evolved in a situation where visibility was very poor. So the brains are more attuned to interpret stimulus that are very near. Stimulus from far away at a distance and stimulus that are coming far detached in time are difficult to comprehend for the brain in general, and this feature is seen in human brain also. So several cognitive fallacies are all there in humans, and the list of cognitive fallacies is quite large. Take a few examples: availability heuristic, confirmation bias, framing effect, planning fallacy, Peekant rule, etc. are some of the common fallacies which human beings have. So if you construct an artificial intelligence which is mimicking a human brain, it is most likely to be also having these kind of cognitive fallacies. Of course, when you are designing something from grounds up, there could be a way in which you can make it more perfect than a human brain. One application on understanding the geological world is the application of geostatistics. Geostatistics is a misnomer. It is not statistics. It is not based on a mathematical foundation that statistics normally is. From my own experience in using geostatistics is that it can give some results which are within the ballpark. It could be, in many cases, widely off from the mark. It could be underestimating the reserves or overestimating the reserves by big margins in many cases. But in many cases, it is giving the answers within the ballpark. So it should be, when you are using geostatistics, it will be very prudent to compare the results with other traditional methods. Similarly, artificial intelligence could come with results which may not be accurate because of the intricacies, the complexity of the natural systems. Artificial intelligence will be able to ease some task like interpretation of geophysical data. It could replace experts who are hard to find today. So you can get the results faster, and that could help exploration. But I fear it could also create an environment of political pressure of using these exotic software tools. It could become a political necessity. But still, artificial intelligence holds a lot of promise. If the artificial intelligence systems can overcome the evolutionary limitation of the human brain and provide answers which can overcome the cognitive fallacies human beings have, then it could be of some real use. Not only in finding new discoveries of oil and gas and minerals, such systems can be used in making the production of oil and minerals more sustainable, reducing waste, reducing externalities, and improving efficiencies, improving your land footprint, improving your carbon footprint, etc. could be accomplished by the use of artificially intelligent systems. This is where research should look into, not just providing narrow artificial intelligence that can automate some tasks. Of course, certain of that will be very useful and will be used by the industry, but the real power of artificial intelligence will come when it can provide answers from a systems view, looking into the area which has got organized randomness, the extremist area, and give answers to such questions. We will stop here. As I remarked earlier, your comments will be very welcome and useful for the improvement of this podcast. Please provide your comments through email or through the public Reddit forum. Goodbye.